Swayam Prabha. Digital India. Educated India.
Good day to all of you. Last time, if you recall, we finished the discussion on liners for landfills, and today we will move on to covers for landfills. And just to recall, I mean, the philosophical concept was that we'll have a cover, a liner, and two straws to take out the gas and leachate. So cover, liner, gas collection, and leachate collection. So we have finished this aspect. Today we are starting this, and in the future lectures we'll look at leachate collection and gas collection. But if you will recall, we are basically having the philosophy of a dry tomb landfill, right? And dry tomb means no water should get in and no water should get out, and no gases should get in and no gases should get out. Whatever has to come out by in these two straws, the leachate collection pipes and the gas collection pipes, because then we can control them, we can do whatever treatment and control that we want to do on these two sets of emissions. So when you look at the cover, for a below ground landfill the cover is less. For an above ground landfill, the area of the cover is more than the area of the liner, and for a side slope landfill they may be of similar magnitude depending on the shape. And when we talk of covers, you remember we talked about daily covers, intermediate covers, monsoon covers, and final cover system. So daily cover is what is the soil we put on top of the waste every day. And how thick is it typically? 15 centimeters, 6 inches, 8 inches at max, whatever you can conveniently put with a dozer or earth moving equipment which spreads soil. Intermediate covers are those which are placed at the end of a phase or at the end of a year. Our attempt is to put the final cover, but at the end of the year, if we are not able to put the final cover on the working phase, then we put an intermediate cover which is thicker than a daily cover. And we will recall how thick was this intermediate cover. Anybody recall the thickness of the 60 centimeters? No, 60 centimeters is a little excessive. I think it was more like 45 centimeters. That's the kind of thickness that we use. Monsoon covers are temporary covers put for the 3 or 4 months or when it's raining, right? And these may be in the form of removable covers. One, they are removed after the monsoons are over, but even within the monsoons, if you have a window, within the monsoons, if you have a window that the rain has stopped for 2 days and you want to place your waste, then you should be able to remove it. So most of them are like flexible polymeric covers, but they are not like thick polymers because these are temporary covers only to keep out the rainwater. And final cover systems are what we are going to discuss today. And the word is now not a cover but a cover system, which means it is more than one material, more than one layer. So what are the functional requirements of covers? they must not allow rain water to get into the waste, because then leachate will be formed. If some rainwater gets into the cover, it must encounter a hydraulic barrier, similar to that in a liner. Simultaneously, if you are collecting gas for the purpose of energy recovery or for the purpose of minimizing greenhouse gas emissions, then it must also prevent landfill gas from escaping. So far, when we looked at a barrier, we were looking at a barrier to water when we were looking at the liner system. But now we are looking at a barrier which must also prevent landfill gas from escaping. Of course, if you have a waste which is not producing any gas, which is not biodegradable, or which is not having any methane emissions, then this is not a primary concern. However, if it is municipal solid waste with significant biodegradable content, then you have to prevent the gas from escaping. One of the requirements of a cover is, just like your roof, the roof is slightly tilted to enhance surface runoff. Water should not pond over it. Similarly, the cover must have slopes which enhance surface runoff, and it should not be erodable. It should not be that water flows on the cover and carries away fine particles, makes erosion gullies, and that kind of erosive processes must be withstood. Vegetative green covers are very soothing to the eyes. So from purely an aesthetic point of view, when you clear these large dumps or mounds, you like them to have a green look, so you must be able to grow vegetation on it. Now, I am not saying you can grow vegetation in a desert. So if you are in an arid climate where rain is very less, we'll look at alternate covers. But wherever there is greenery in the natural environment, that means there is some self-sustaining vegetation in that environment. So you must have a similar situation as far as the landfill is concerned. The covers must withstand long-term settlements. Now, when we talked about liners, we were talking about the fact that clays are flexible and membranes are flexible, and they would be able to overcome the settlements in the soil. But covers, if they have biodegradable waste, have much larger settlements. So the covers should be able to withstand large settlements if there is organic waste or biodegradable waste. Covers have long-term slope stability problem. If you look at this cover or this cover, this slope is going to remain exposed for the design life, 50 to 100 years. There should be no erosion, there should be no slope instability, the hydraulic barrier should not get exposed. Same thing here. Liner gets buried, so their slopes are temporary. So therefore, slope stability problems are much more in cover systems. And when you are exposed on the surface for years and years, design life 50 to 100 years, then you should be able to withstand if there are any vehicles which are going to move on the cover. These may move for maintenance, these may move for other purposes. Extreme winds, extreme sun, extreme hurricane, extreme tornadoes, what else? Extreme earthquakes. Everything for which your building should be stable, these covers should be stable as well. Liners are now buried and they are not being subjected, they are being subjected to leachate, which is a very different issue than the covers. So can the following perform satisfactorily? One of the ongoing practices in municipal solid waste disposal is to put a soil cover. And these old waste dumps with the soil cover are often referred to as sanitary landfills. But soil cover is not necessarily impermeable, but it does allow you to get some vegetation to grow on it. So does a soil cover meet all that we are trying to say in the earlier slide? A soil cover, a local soil cover, a local topsoil cover will support vegetation if there is vegetation in that city. But it will not perform much of the other functions. It will not be a hydraulic barrier, it will not prevent the gases from going out, so a soil doesn't work satisfactorily. It may work on a horizontal surface purely for aesthetics, but on the side even the soil can start to get eroded. Concrete will not work on waste. If you look at concrete, that is, it's a rigid system, and therefore it will not work on a large settling mass. So immediately the thought comes, maybe what we used in the liner, can we use that in the cover? And did you, when I showed you the geomembranes, what was the color of the geomembrane that I showed you? I showed you the geomembrane, smooth and textured. What was the color? What are the color of most of the overhead tanks? Yeah, because carbon black is used in all the polymers to withstand ultraviolet rays. So typically these polymers are black in color. You can make them colored as well. But the issue is, if you use a geomembrane and clay, it will be a good hydraulic barrier, but if it has to remain exposed for 50 to 100 years, one is the aesthetics issue that it's a black tomb, the other is open to vandalism. It's open to vandalism. Children will come and play on it, and people will drop something on it. So obviously just by itself the geomembrane and the clay can be a good barrier, but it is not suitable for long-term stability for 50 to 100 years. The way concrete is. I mean, you can leave exposed concrete and that will survive 50 to 100 years, but you can't leave geomembrane and clay. So obviously we need to look at this a little more carefully. So first issue is that covers have to perform all the functions which are performed by the liner, except that they don't come in touch with leachate. If you have designed your system well, you will not have leachate coming in contact with your cover. But covers undergo much larger settlements, so they will be different. Covers have to drain off much larger volume of water. The leachate that is generated is the amount of the squeezed liquid which comes out and part of the precipitation which gets into the waste. The leachate quantities are smaller. What falls on the cover has to be handled by the cover, and it's the full peak rainfalls. So covers have to handle much larger volumes of water. Liners along side slopes become buried with time, hence the slope stability issues are temporary, but slopes of covers are permanent and require long-term stability. And as I said, the covers are exposed to wind, rain, sun, snow, traffic, burrowing animals, plant roots, etc. The advantage is covers are repairable. They are right at the top. So you can dig them up and repair them. Liners you can't repair, especially if a lot of waste has come on top of them. And covers are not exposed to leachate. So if I look at a liner, let me look at a liner here first. Waste, separator, leachate collection system, a composite barrier, there is a separator on top of this if required, then another separator, then the secondary leachate collection system, composite barrier, and the subgrade. So that's a cover. Typically, that's a liner system which we saw, and this is a double composite liner for hazardous waste. I'm going to look at typical elements of a cover system. Because cover must have green look and vegetation on it, it needs to have a topsoil layer. Then there is something called a protective layer. We look at the functions of each of these layers. If any water goes in, which it will, because you want to keep the grass green. If you want to keep the grass green, you have to irrigate it. If you irrigate it, some water will definitely go in. So there is a lateral drainage layer that if any water infiltrates through this, it drains out so that it should not stand on top of the barrier. The barrier here is shown doesn't have a geomembrane. It says S/C. S is for single barrier, C is for composite barrier. Liners will always be composite. Covers can be single barriers or composite, and this we will try and understand a little more. The waste is at the bottom. Gases are emanating from the waste. If I put a barrier here, then the gas pressure will build up. So there is a gas collection layer above the waste. Okay, there's a gas collection layer above the waste, and there is a foundation layer. What's a foundation layer? Between the gas collection layer and the waste is a little bit of material which is put to smoothen out the surface and to give you a strong surface for the other components to come on top. It's basically compacted local soil. It may or may not be required. Sometimes what you may do is you may put a little bit of extra gas collection layer and say, okay, this will take care of my foundation layer. So in some countries this is essential. In India this is optional. If your waste is soil-like, means what? If the particles are not very large and protruding, and furniture components and construction and demolition blocks, then there will be no protrusions from the waste. If it's soil-like, say it's in sand and size below, then the waste itself can form the foundation layer. But if there are big particles, heterogeneous material, then you'll need to put extra material on it to cover it. So that's the foundation layer. So the surface layer which we saw, on which we grew vegetation, is predominantly for a green look, for erosion control and vegetative growth. So vegetative growth means green look, erosion control means you don't want the soil to erode, right? And can we put a soil which will not erode? Can we put a soil which will not erode? Any thoughts on soils which do not erode? Typically gravel will not erode, but you will not get a green look. So you will get a huge mound with a gravelly grey look, and that is the issue. But in arid climates you may have no other option because you may not have sufficient water. You are not trying to create a green park in a desert. So we can have erosion control other than vegetation, but wherever we can grow vegetation, that's one of the ways we do it. What is the protection layer? So typically how deep should be the surface layer? What would govern the depth of the surface layer? I said the surface layer will be made of local topsoil on which vegetation grows. So how thick do you think it should be? 10 meters, 1 meter, 10 centimeters? Depends on the type of vegetation. Why? What has vegetation got to do with? Depends on the size of roots. Okay. So let's carry this discussion forward. Surface layer thickness. I said it's made of topsoil. I want to grow vegetation on it. Do I want to grow grass or do I want to grow local vegetation? I want a green look. Let's start with grass. Grass is not it's not inexpensive. The kind of grass you have in lawns, the IIT lawn, it's not inexpensive. You have to maintain it. So we said that the thickness will depend on the root zone. One of the considerations is root zone. So if I have grass, what should be the thickness? If you say 6 inches, 15 centimeters, 150 millimeters, right? Because the grass itself is not going to be taller than 6 inches. So the grass roots are not going to be very big. But you have been told to restore the land to its original condition. Is that right? Isn't that what we said, that whenever we walk off after 50 years, there should be original vegetation? And original vegetation can only grow if it has sufficient root depth. So if original vegetation is a tree, or is it a shrub? So if you look at your hometown and think about when you're traveling on the highway out of your city, what do you see on the roadside? Shrubbery more or trees more? So you don't have anything on the ground. It's only a tree and a brown patch beneath that. What covers most of the ground other than the agricultural field? Yeah, you have trees. They are more visible because they are larger. But you will not have a canopy of trees. Some places nothing may be growing, but most places you will have local shrubbery. Shrubbery may be either in the form of a little tall grass or shrubs which may be a foot high, some kind of a wild growth, right? I do remember that I went to the Jim Corbett Park and they have grass which is taller than me. So there are different types of grasses and different types of shrubbery. So if you walk in that grass, you are always worried that there's a tiger on the other side, a few meters away, right? So anyways, most of the places will have local shrubbery. If you want to grow a tree on a landfill, what is the root penetration depth zone you need? So let's end the discussion on this. Suppose you say, I want to grow trees on my landfill. So what is the root penetration depth that you need? Tree may be how high? It can be very high, but let's take a normal tree. 3-4 meters high, agree? Maybe a little taller. Then what do you think will be the root depth of a 3-4 meter high tree?
2 meters, 1.5 meters.
Okay, 1 meter. So immediately please see what is happening. The moment you go from a grass to a tree, the surface layer is becoming very thick. So first remember, it's not easy to grow trees on landfill surfaces because you need to put in a lot of soil. And that's a challenge because the moment you make it very thick, you have to get the material from somewhere and you have to lay it and compact it. But if something is in your mind that I want to put trees, then you'll need several meters. If you want to put shrubs, about half a meter, 50 centimeters. So I'm just giving you some figures. So grass, 15 centimeters or 0.15 meter. Shrubs, and trees. So trees we said in meters, 1 to 2, some people said. Shrubs will be about. So now you've got an idea as what should be at the top. Okay, let's come to the protection layer, the second layer that we are talking of, protection layer. So why do we need a protection layer? Below that is going to be the barrier layer. What is it about the barrier that we need to protect? So we had all these issues. Can we have a geomembrane and clay at the top? I mean, that is the discussion. You want green finish? I'll give you green geomembrane. Is that fine? Or you don't like look of green plastic? So green geomembranes are available and they have been tried. But eventually, are you going to say nobody can walk on this? Are you going to fence it off and put a tala and have a security guard there that sees that no animal? Well, he will prevent children from coming, you will fence it and put a gate. Then somebody will hop over the fence. Then you will make the fence higher. Then the birds will fly from the top. And then what will you do? So you have to protect your barrier. So what can trouble your barrier? If what's happening in Srinagar today, lots of snow, My cars are buried. So you have to protect your barrier from snow, from rain, from burrowing animals. And if you grow shrubs at the top, you don't want them reaching your barrier and going through them, because then when the shrub will die, it will become a preferential seepage path. So you have root penetration. By mistake, somebody may start digging. Somebody wants to run a telephone cable, well, now everything is mobile, but somebody wants to run any line, any utility line, and he starts digging. So we don't want it to be damaged. So the function of the protection layer, as you can see, is protect the underlying layers from desiccation, frost, root penetration, burrowing animals, accidental human intrusion or others. And these may also be half a meter, typically half a meter is sufficient. Unless you belong to a cold country, they have a frost penetration depth curve for the various regions. So you will know that so much of the ground freezes below the ground level, and that's called the frost penetration depth. So you would have to have your protection layer more than the frost penetration depth. So you have to put a protective layer, and after you have come below the surface layer and the protective layer, you can put your barrier layer. And if I try and develop this now, surface layer for vegetation, protective layer to prevent anything, and let us say, for the simplicity of argument, that my barrier layer is simple clay, compacted clay. So you will have a barrier layer here. Now your design must be like the roof. Minimize infiltration by having a sloping roof. So the philosophy is that whatever is falling should run off. The best way to run it off is to pave it. If you pave it, then the infiltration will be less than 10% of the precipitation. But what is the problem with paving? You can't pave it with concrete. Maybe the road engineers will say we can pave it with bitumen. But do remember, what is the kind of settlement that we have in municipal solid waste landfills? I said some percentage of the height. We had done it while planning landfill capacity. Do you recall? 0.1% of the volume. Pardon? 0.1% of the? No, I think I said 15%. 15% of the height. So if you have a 10-meter high landfill, so it will settle by 1.5 meters. Now bitumen is not going to take that kind of a settlement. In any case, bitumen is going to be black. So if you want a blacktop, coal-tarred pavement, that's an aesthetics issue again. So we must have a material which can take large settlements. So we come back again that the barrier layers have to be flexible, and on the top, if you have a good vegetative cover, your infiltration is going to be low. So your inclination has to be there, and a good erosion control measure also gives you low infiltration. But some water will come through because you're going to make the grass grow. Once you're doing irrigation, water is coming through, and it will come and sit on top of your barrier layer. Now, what you're doing at the top, you again do it on top of the barrier layer. If some water comes through the grass surface layer and through the protective layer, remove it. So therefore, you have a drainage layer. You don't want any water to pond up on the barrier layer. The moment the water ponds up on the barrier layer, what's the problem? It will go through the barrier eventually. So therefore, you have a drainage layer which again removes the water. Precipitation, runoff, some infiltration, and some lateral drainage. So in a sense, water doesn't stay on the roof and it goes to the toe. So that's the function of the drainage layer, to reduce the head of water on the barrier layer, zero head, and drain away the water which is coming from the overlying layer. And that brings us to the discussion on the barrier layer. What kind of barrier layer do you want? One which allows zero water to go in, or one which allows some water to go in? Zero water is ideal in the sense there will be no leachate, or only the leachate from the products of reaction and what is squeezing out, and therefore leachate treatment cost will be a minimum. But if you want your landfill to stabilize, your municipal solid waste, you stop water, it will stop biodegrading. You have already stopped oxygen. Please understand, when the waste is lying on the roadside, at least it's in contact with the air, shallow depth. The moment you put so many layers of waste and you put a daily cover at the end of the day, there is no oxygen which is inside the waste. So it's becoming from an aerobic condition to an anaerobic condition. If I make the dry tomb landfill, then no water goes in and the biodegradation even becomes slower. I can't stop biodegradation, but it becomes slower. The more the moisture, the faster it degrades. The more the oxygen, the faster it degrades aerobically. So there are two schools of thought. For the hazardous waste landfill, which doesn't have biodegradables, which is mostly sludge and inorganics most of the time, you will have a composite barrier, similar to the one that you have for liners. But for municipal solid waste landfills, you may have a single barrier. The idea is most of the water which falls and comes through will go to the side, and some percentage of it will go into the landfill. And that's not a huge amount. It may be 10% or 15% or lesser of the total precipitation, maybe 5%. The leachate will be formed, but it will also biodegrade the. So the two philosophies: one, allow municipal solid waste landfills some water so that they stabilize. The other is allow no water. Now, if your waste is becoming totally segregated at the source and the biodegradable component is going to the composting plant, then what kind of a cover would you adopt? Composite, because there is nothing biodegradable in it. Then you can keep it as composite. Purely as another thought, maybe I'd like to wash my waste. No, if there are some leachable salts in it, something which dissolves, so maybe my biodegradables are gone, but let me wash my waste so that it becomes stable. So I had this discussion with you, again this is only at a philosophical level, that when the leachate comes at the bottom, you have to treat the leachate. To treat the leachate, you have to send it in an effluent treatment plant, or just conceptually into an evaporator, let us say. So in an evaporator, the liquids will be evaporated and some solids will be left. But these solids will all be soluble. At the moment, these solids are brought back to the landfill. So if they are brought back to the landfill, the contaminant is just going round and round. If we have a technology that the solids come out of the effluent treatment plant or from an evaporator and we glassify them, or we do something such that they become non-leachable. At the moment it's a salt. When you evaporate something, it's a salt. You put water in it, again it will become into a solution. So that we have not changed the solubility of the contaminants. And I'm not only talking of heavy metals, I'm talking of contaminants like chlorides and sulfates, which will precipitate out. And the moment you bring it into the landfill, they'll again come into the leachate. So till there is a strategy of entrapping them. So one of the thoughts which goes on is, let's put them in building blocks. Building blocks are inert. and if you put them in building blocks, they'll be held inside. But you can't prove to me that if you put them inside a cement block, that after 100 years they will not be released. See, glassification means putting them inside a matrix where they will be there for thousands of years. Man-made materials are typically there for hundreds of years. So that is the issue. You remember that movie, the Jurassic Park? In the Jurassic Park, how did they create dinosaurs? There was a mosquito inside a golden glowing resin blob. So what had happened was that the mosquito had bit a dinosaur. It had the blood of the dinosaur inside it, so it had the DNA. And while it was sitting on the side of a tree, it got stuck to the resin, and the resin entrapped it. Consequently, it became entrapped in an inert matrix, and you could go and take out the DNA from inside. But then this survived for thousands of years. Whereas we have concrete, which I don't know whether it survives for thousands of years. Rock does. So anyways, so the point is, the philosophy of whether this should be impervious totally or have some little bit of, allow some little bit of water, is a debate which goes on infinitely. Currently, the state of the art is, if you want your municipal solid waste to, stabilize, allow some water. So therefore, you have single liners, typically a compacted clay liner in municipal solid waste, and you have a composite liner in a hazardous waste cover. Then just like you have a drainage layer at the top, you have a gas collection layer at the bottom to collect the gases, and below that you have waste. If the waste is such that there are no protrusions and no non-uniformities, and a dozer can make it plain and it can be compacted, then you don't need a foundation layer. But just suppose if it's just food waste, wet, soggy, non-soil like, then before you put your gas collection layer, which is also sand and gravel, you would like to put an intermediate soil layer on it. So there's a foundation layer which comes up optional, which you have. So that's your cover system as it is adopted. So if you look at the municipal solid waste management rules in India, here is what it has. It says 45 centimeters of topsoil on which vegetation will grow, 15 centimeters of sand as a drainage layer, 60 centimeters of compacted clay, as was the case, 10 to the power of minus 7 centimeters per second, 30 centimeters of sand gravel. So doesn't seem to have any protective layer and doesn't seem to have any foundation layer. So that depends on the designer. Please understand, a protective layer, if it is made of the local soil, let me again say, you are going to grow grass, so 15 centimeters of surface layer is fine, and the protective layer is also of the local soil, that's 45 centimeters. Both things put together is called a topsoil layer, and here they have given 45 centimeters. It could have been 60, but it's 45. It works both as a surface layer and a protective layer. Where topsoil is very limited, there you will have a separate topsoil and a separate protective layer. And for the hazardous waste landfill, the following are the specifications. Now you have a 60 centimeter topsoil, the surface layer plus protective layer, a drainage layer of 30 centimeters, a geomembrane and compacted clay liner. This is called a regulatory layer. Now, why is it not called a gas collection layer? There may be no gas coming out of a hazardous waste landfill. There may be some volatile organic compounds. So it can be a gas collection layer, or it can be a foundation layer, or it can be both. So this word regulatory layer, I think, comes from Germany, which they put here. So that's for a hazardous waste cover system. And if I go back to our discussions on separators and filters, vegetation, topsoil, you'll need a separator between the drainage layer and the topsoil. right? And it should be a separator cum filter. It can be a geotextile, it can also be soil. Then between the drainage layer and the compacted clay liner, you will need another separator. Compacted clay liner, it's sitting on the gas collection layer, another separator and a filter. So many interfaces have to be taken care of. And when you come for hazardous waste, you have more interfaces. The same number of interfaces, except now the geomembrane is in intimate contact with the compacted clay liner. And the important thing here is that in this system, something else is also written at the bottom. This is a cover for hazardous waste landfill or cover for a municipal solid waste landfill with gas recovery. If you are going to design a landfill to extract the gas and generate power from it, which is what in many landfills in the US you will find that they are extracting the gas and generating power. You don't want to lose any gas to the atmosphere. Now, if you have only a compacted clay liner, please understand that for gas the permeability is higher than for water, typically. So a compacted clay liner will not be effective in holding your gas. If you are intending to have a municipal solid waste landfill with a gas collection system, please put a geomembrane here, because the geomembrane is much more impermeable to gas than clay alone, and therefore you should have a geomembrane at the top. But if no biodegradables are going to come to your municipal solid waste landfill, no significant gas not required. But if your waste stream is not segregating itself out, composting plants are not able to take the waste because it's too mixed, then it might reach a landfill. And if it reaches a landfill, and if you want to extract gas for it, please have a geomembrane in the cover system, though it is not prescribed in the minimum rules. So we can have different alternatives for the various components. We talked of a surface layer. It's a topsoil with grass is what we have talked about. If grass will not grow, maybe you will put artificial turf on it. You want a green look, like a hockey field? Artificial turf. There are artificial turfs which exist. You can have geosynthetic mats. You can have cobbles. If you are in an arid climate, you can have cobbles or gravel if it is available nearby. You can have paver blocks. You can have rubble masonry. Some rubble is discarded construction and demolition waste. You can put some cement and make a rubble masonry from it. Or you can have geocells with soil, etc. So there are a lot of options which exist. This is the most often used, because in the end you have to make your cover for restoring the land to its original condition. If you are making a short-term cover, then you can do all the other things, right? Similarly, for the protection layer, as I said, mostly you have only the same alternative, use local soil. Local soil can be different from local topsoil. Topsoil is the one on which the vegetation grows. If you dig a little deeper, you may not have soil on which the vegetation grows, but you can use it as a protection layer. For drainage, we are going to talk about, we have talked about use of sand and gravel, just like the leachate collection layer above. But we also have other geosynthetics which we use. We also have other geosynthetics which we use, and we will discuss this in the next lecture. I'll show you some of these materials. Barrier layer for municipal solid waste, compacted clay. For hazardous waste, geomembrane underlain by compacted clay. Even when you want to have municipal solid waste with gas collection, you will need a composite liner, geomembrane underlain by compacted clay. If clay is not available, there is a tendency to replace the clay with a geosynthetic clay liner at the top. Okay? Gas collection layer, sand and gravel, a geocomposite, and I've already said geomembrane is essential for gas collection. If you don't want to collect the gas gets vented out. You can still collect it, but you're not taking it, you don't want high efficiency to make energy out of it. If I'm making energy, I'm the owner, I want 100% of the gas collected, right? If I'm just venting it, I can send the gas through vents where 50-60% efficiency is also acceptable. The rest will go out through the soil layer on top. So remember, GM is essential for collection for energy, not necessary for venting. The foundation layer is made of soil. So these are the alternatives which exist. We will stop here at this point, and in the next lecture we will take up what are the non-man-made materials which are used to replace some of the layers that we have seen. So far all we have done is added a geomembrane in a composite liner as an add-on to a compacted clay liner. But now more and more the attempt is to make the cover lighter, less thick by putting in thinner elements. If I look at the thickness of this cover, 60 plus 30, 90 plus 60, 150 plus 30, 180, it's more than 2 meters thick if I look at the separators as well. So that's a huge thickness. So no landfill owner wants to lose 2 meters of thickness in a 10 or 15 meter high landfill. So can I put something else? Can I put something else? We'll look at it in the next class. Thank you. Any questions which come to your mind at this stage? No questions. But do remember that once you put man-made materials, you have to be very sure about the life of the man-made materials in comparison to natural soils, which we can be sure. If I put sand in a drainage layer, how long will the sand last? What's its life? Just a discussion. What's the life of sand particles? 5 years, 10 years, 100 years, 1,000 years, 10,000 years? Take a pick. At least 1,000, if not 10,000. At least 1,000, if not 10,000. Geomembrane, take a pick. 5 years, 10 years, 100 years, 1,000 years, 10,000 years. 100 to 200. Even the manufacturer will say, sir, this will last for 200 years plus. Our design life for the whole system is 50 to 100 years. So man-made materials will not last for 10,000 years. So if you are bringing back landfill to its original condition, you have to take into account that after a certain point of time, the man-made materials will not be there. That's fine. If the waste has become stable, if the emissions are within limits, it's fine. It's now harmonized with the environment. But otherwise, man-made materials are not going to survive in a geological time frame, whereas the natural materials will. So we'll carry on from here in the next class. Thank you.